So here's some problems from section 1.5, and this is number 23, and all we want to do is find the inverse of this function. F of x is 2x plus 1 all over x plus 3, and it's a one-to-one function. You can check it by graphing it. So let's graph it anyway just to check it. So let's press on, clear that, and that's going to be, oops, can't see it anymore. There it is, 2x plus 1. So we'll say parentheses around the top of the fraction, 2x plus 1, parentheses, and then we'll divide that by x plus 3 divided by x, parentheses, and then x plus 3 parentheses, so there we go. And then we can go zoom 10, zoom 6, which is a 10 by 10. And there we go, you see it's looks like kind of a variation on swoosh, flipped around, something like that. Looks like we've got, well, not quite, because it looks like we've got asymptotes that are up here. Actually, we do have asymptotes. Horizontal asymptote here and a vertical asymptote at -3. And we should remember this from our polynomial functions, and this is a lot what you're going to be doing in that summer review number 7, but since these powers are the same, then we just look at these are polynomials, we look at the ratio of the coefficients of the highest degree terms. The highest degree is 1 here and 1 here, so that ratio is 2, so 2 over 1, so we do have a horizontal asymptote at y equals 2, so that's this one here. And then we've got a vertical asymptote at x equals -3. I can't graph that, but I can graph the horizontal asymptote y equals 2. I can go back over here, graph that, and there you see that asymptote. So there's that asymptote. Okay, we can see that. So that's the asymptote because the ratio here is 2 over 1, y equals 2. And again, there's your vertical asymptote, which we can't graph, but it's a vertical line. Okay, so it is 1-to-1. Looks like it passes the horizontal line test. So let's go to work and let's find the inverse function. So first of all, we follow our basic rules. Instead of f of x, we write y. It might have been set up like this, but normally we see it like this. And then we interchange the x and the y, so x goes over here, and then I have 2y plus 1 all over y plus 3. That's what I've got. And then we have to solve for x. So we have a fraction. We've got a y in the denominator, so what I'll do is I'll multiply both sides by y plus 3, and what in reality that does is that brings the y plus 3 over here, and this y plus 3 over y plus 3 becomes 1. So we have x times y plus 3 on the left, and just 2y plus 1 on the right. And then I use the distributive property and multiply out so I can get all my y's on the left. So that's what we'll do. We'll multiply. X times y is xy, x times 3 is 3x, then I got 2y plus 1, and then I'll subtract 2y from both sides, so I've got xy minus 2y, and then I'll subtract 3x from both sides, so I've got 1 minus 3x, right? So I can subtract 2y from both sides and subtract 3x from both sides, and this is what you end up with. Now we're trying to solve for y, so we've got y in both these terms, so we'll factor that out. And the right side stays the same. And then we'll divide both sides by x over x minus 2, and there's our inverse function. F inverse of x equals 1 minus 3x all over x minus 2. Now we have to verify it. So first of all, we're going to check to see is f of f inverse of x equal to x. So f inverse of x, so it's f of f inverse of x and f inverse of x right here. This is the f inverse rule, 1 minus 3x all over x minus 2. Now, what is the f function rule? We have to go back to the top, and that was 2 times something plus 1 all over that something plus 3. So I kind of outlined it over here. 2 times something plus 1 all over the something plus 3, and that something in this case is the f inverse of x. So every time I want to see that x in the original f of x, I'm going to put 1 minus 3x over x minus 2, 1 minus 3x over x minus 2. Now we have a complex fraction, and the easiest way to simplify that is by multiplying the top and the bottom by the LCD, which is, this case is x minus 2, so we multiply the top and the bottom by x minus 2. So x minus 2 over x minus 2 is 1, so I've got 2 times 1 minus 3x, and then I've got 1 times x minus 2, and on the bottom, x minus 2 over x minus 2 is 1, so I've got 1 minus 3x, and then I got plus 3 times x minus 2. Then we'll multiply these out using the distributive property, 2 minus 6x plus x minus 2 on the top, and 1 minus 3x plus 3x minus 6 on the bottom. And then if I simplify, 2 minus 2 is 0, so I got negative 6x plus x is negative 5x. Negative 3x plus 3x is 0, and 1 minus 6 is negative 5. Negative 5 over negative 5 is just 1, so I get x. And now we have to do the second part. Verify if f inverse, this is 23 continued, it's kind of a long one. So let's verify that f inverse of f of x does indeed equal x. So again, f of x, remember, was 2x plus 1 all over x plus 3, so we'll put this in. And the f inverse of x rule, that was, let me go back over here, you can see that. That was 1 minus 3 times something over that something minus 2. So 1 minus 3 times something all over that something minus 2, so I kind of wrote it leaving spaces. And then I put in my f of x. So the green is the f inverse of x rule, and the blue is the f of x rule. So we just substitute that f of x rule in for every time we see an x in the f inverse rule. And again, we have a complex fraction, and again our LCD is x plus 3, so I'll multiply, oh I'm sorry, not again. It was x minus 2. Now it's x minus 3. So multiply the top and the bottom by x minus 3. 1 times x minus 3, multiply the top and the bottom by x plus 3, excuse me. And then 1 times x plus 3 is x plus 3. And negative 3 times 2x plus 1, because x plus 3 over x plus 3 is just 1, so I just have negative 3 times the top, 2x plus 1. And on the bottom, x plus 3 times x plus 3 is 1, so I've got 2x plus 1 minus 2 times x plus 3. Then I'll just x plus 3, then I use the distributive property, negative 6x, negative 3, and on the bottom I've got 2x plus 1, and negative 2x, negative 6. And then 3 minus 3 is 0, negative 6x plus 1x is negative 5x, like in the last verification. And then 2x minus 2x is 0, and then 1 negative 6, or 1 minus 6 is negative 5. Negative 5 over negative 5 is 1, so just 1 times x is x. So this is very similar to the other verification. But again, these were different. Okay? So that's 23. Just a good chance for you to make sure you can do all the algebra without making some simple errors. Hope that makes sense.